Alright guys, just a few more minutes with looking at naming for today. Looking at transition metals, Mr. Akins and I have already talked to you about the fact that transition metals are called transitions because they have different charges, or they can transition back and forth between different charges. So, for example, iron can be iron plus 2 or iron plus 3. This causes a little bit of a problem when we're trying to name or write the formula because we have to identify which charge we're working with, and you will only be working with one charge at a time to be able to name these appropriately. So just so you can kind of see why transition metals are a little bit a pain, I guess the best way to put it. You can kind of see all these different charges. Remember, zinc's row is plus 2 all the way down, and remember, silver's always plus 1. You should have these written on your periodic table. But notice manganese. It has 5 different charges we have to work with, and they vary. Ruthenium has 4. Tungsten has 2. So being able to keep track of these is not important. I'm never going to ask you, or we're never going to ask you to memorize the fact that molybdenum is plus 6, plus 4, plus 3. That's silly. You don't need to be able to do that. What you need to be able to do is be able to use them and name them based off a chemical formula. Okay, so in this case, when we're naming ionic compounds with transition metals, we're going to name them just like we always have been, where we're going to just name the metal. But in this case, because the metal has different charges, we're going to identify the metal's charge using Roman numerals. I'll show you what that means in just a minute. And again, we'll change the ending of the non-metal or the anion to IDE. So let's go back and actually grab this one. Sorry. This is not just going to be iron chloride. It can't be iron chloride. We have to know what iron we're working with. The way we do that is determining its charge through a method we call the uncross unswap. So remember, we have the cross and drop where we drop the charges. Uncross unswap, it means we're actually going to bring up these numbers and make them charges. So in other words, the 3 comes up to the iron, making it iron plus 3. Remember, this is a 1 down here, comes up to the chlorine, making it a negative 1. Now, how do I know iron's plus and chlorine's negative? Well, again, look at your periodic table. Iron is a metal, therefore it's automatically positive. Metals form cations. And then chlorine is a non-metal, automatically forms anions, so negative. Just in case you're wondering where those numbers come from. So simple, easy as that. We figure out our charges, and now we just name it. So iron plus 3 is iron parentheses 3. Okay, and some people do the parentheses, some people don't. I always do just because it's the way I like it and the way I learned it. It's up to you. But the important aspect is that you have iron and its charge and Roman numerals, and yes, it has to be Roman numerals. And then chlorine, of course, is chloride. Well, why didn't we have to identify the Roman numerals for, let's say, calcium? Okay, why didn't we say calcium 2 or anything like that? Well, because calcium is only ever a plus 2 charge. That's how it always is off the periodic table. We only need Roman numerals when we don't know the charge, or when there's multiple charges, I should say. Calcium's always plus 2. We don't need a charge. Guess what? Same for silver. Silver's in the transition metals, but I don't need to say silver 1 because I know silver's always 1. I just say silver. It's just when they have different charges that we have to use the Roman numerals. So please do not start putting Roman numerals with sodium or calcium or aluminum or anything like that. It's just within that D block, or that transition metals, except for zinc's column, so zinc, cadmium, and mercury, and then silver. Those are the 4 that have consistent charges that don't need Roman numerals. Everything else in the D block needs Roman numerals. Remember, this also includes tin, SN, and lead, because they can have different charges as well. They are technically not part of the D block, but they act like transition metals in the fact that they can be plus 2 and plus 4. Okay, so let's look at another one, FeO. Well, we'll start by uncrossing and unswapping and bringing up our charges. Well, this is going to give us iron plus 1 and oxygen minus 1. Again, remember, they are plus and minus because of their positions on the periodic table. Now, what's wrong with this picture? Okay, well, what's wrong is the fact that oxygen is a negative 1. If you look on the periodic table, oxygen's not negative 1. It's negative 2. So that means these charges are not quite correct. It means they were simplified. So you have to unsimplify them. So if it's a 1-to-1 ratio and we know oxygen is negative 2, we know iron must be a positive 2. Okay, so in other words, this is Fe plus 2, O minus 2, if I brought these charges down just to double check my work, it'd be Fe2O2, which would give us FeO, which is exactly what we're looking at. So now we name it. We always go back to the actual charge, which is the 2, so we're going to say iron 2, and then of course oxygen becomes oxide. And again, notice I'm not putting Roman numerals with oxygen or anything weird. It only goes with the transition metals. Again, if I know the charge definitively, I do not need Roman numerals. Okay? So let's just practice a couple, make sure we're getting this. Let's pick some random ones. Let's do this guy and that guy. How about that? And let's throw this one in too. So, uncrossing and unswapping, we are going to get NN plus 1, O minus 1. Oops, sorry. I'm saying minus 1 and writing minus 2. My bad. Minus 1. Now again, remember oxygen should be a minus 2, so this actually is going to be NN plus 2, O minus 2. So we are going to name this as manganese 2 oxide. Okay, down here, uncrossing and unswapping, we are going to get Fe plus 2, N minus 3. And nitrogen is supposed to be a minus 3, so we can just name this guy as it is. It is iron 2 nitride. Okay, and then down here, last one, uncross and unswap, what we are going to get is Cr plus 1, oxygen minus 2, and I'm now going to name this as chromium 1, and yes, you do need to show the 1 as the Roman numeral. The only time you don't show the 1 is like in the symbol, but you do show the 1 in the name if it is a plus 1. And then, of course, oxygen is oxide. Okay, same thing works if we're trying to name them or work them backwards, as I call it. Copper 3 tells us we're dealing with Cu plus 3. And then nitride is N minus 3. So cross and swap gives us Cu3, N3, which of course simplifies to, Cu1N1, or copper 3 nitride. Okay, looking at a couple other ones, we have iron 3 oxide. That tells us we're dealing with iron plus 3, oxygen minus 2. Please note that this is not the subscript. It is the charge, and only the charge of the transition metal. Some people get confused and say, oh, there's 3 irons. No, there's not 3 irons. It's iron plus 3. It is denoting the charge of the transition metal because we cannot determine it from the periodic table because it has multiple charges. Okay, from there we do like what we have been doing, which is our cross and swap. So iron 2, oxygen 3. So notice here we actually have 2 irons. So if you had put a 3 there because of this 3, it would not have been the right compound. So please, please, please be careful with that. Let's do vanadium 1 sulfide. Again, vanadium would be a plus 1 because of the 1 charge. And then sulfide is a minus 2. So cross and swap, we get V1 S2. And we'll do one more. Some people have a hard time with this Roman numeral. Remember, it is a 4. It is a 1 before 5, so it is a 4. So we have chromium plus 4, chloride, which is Cl minus 1, cross and swap, and we get Cr1Cl4. Okay? I think, yep, that's where we're going to stop. For right now, let's get out of here real quick, and I want to show you what you're kind of doing for your homework so you have an idea. Let's edit this view, if it will let me. View, edit document, there we go. Okay, this is what your homework's going to look like, and we have already put instructions up here, but I just want to go through one of them with you on each page just to make sure we're very clear. So potassium is a plus 1 charge. Sorry, for some reason this is not wanting to write on Word. There we go, plus 1. And phosphorus is a minus 3. There we go. Sorry guys, it's not wanting to write on the Word document for whatever reason. We are then going to write our formula. So cross and swap, and we get K. Let's see if I can just switch it to pens here. Let's see if that writes a little better. A little bit, maybe. Maybe not. Sorry guys. But you basically end up with K3P, and just imagine there's a line there, and of course then you're going to name it, and it's going to be named potassium. It's not lighting the downward stroke, but you guys get the basic idea. Phosphide. Okay. On the back, similar thing. I think you're working backwards on the back. Yep, name's already given to you, so they're basically wanting the formula. Do me a favor. Ammonium is a transition metal, which we're not ready for. So I need to go through and edit this before I print it for you, but that's okay. We'll make this aluminum. How about that? Aluminum iodide. Okay, well, aluminum is Al plus 3, and that's a plus. And then iodide is I minus 1. Okay, so cross and swap, and we get Al I. Trying, guys. Sorry. 3. So that's what you're doing on both sides. I'll go through and edit this and make sure polyatomic ions are not on this before you guys see it in class. But other than that, that's what you're doing for homework. We'll have an answer key up here for you to check, and you are more than welcome to come ask me questions throughout the day if you need to. Okay? Hopefully this helps, and we'll go from there.